So today we'll be covering section 4.8, which is about Earth's geography and climate. The learning objective for today is that you can describe how Earth's geography affects weather and climate. We're going to be talking about how weather and climate are impacted by the sun's energy, but also from geologic factors such as mountains or oceans. And we're going to talk about this concept of a rain shadow and what it is and why it matters. So we are first going to talk about just a little bit of a reminder of what we've covered in some past content. And a general rule of thumb that we can follow is the idea that climate is largely determined by insolation. Remember that insolation is the amount of sun's radiation hitting a certain area. And this is going to be tied to latitude, which is going to impact the angle of insolation and the amount of atmosphere those radiations or the sun's radiations are having to go through. So a general rule of thumb is that higher latitudes receive less insolation and they're going to have cooler, less precipitation. And if you think about the polar cells that we talked about and how you're having areas where when there's low pressure, it moves up and you get a lot of precipitation, versus when you come back down, especially at 30-degree latitude, you're going to have dry air coming down. So they're going to be cooler, they're going to have less precipitation, and they're getting less insolation. Compare that to the equator, which is going to receive the most intense insolation. And again, because of that Hadley cell, you're also going to have high precipitations because this is where you're having air rising. As it cools, it's going to condense. You're going to have rainfall, which is what we see at the equator. However, these are mostly rules of thumb, and they're going to have the biggest determining factor on climate, but we also are going to have aspects of Earth's geography that can impact the areas of climate as well. And so what we are going to be seeing is there's a couple main ways that geography plays a role. The first of all is going to be mountains. And mountains have the ability to disrupt wind and to produce rain shadow effects, which I'll explain more in depth throughout these notes. And we also have oceans. Oceans are going to have moderate temperatures and they add moisture to the air. So although the cells and the insolation are going to have a big impact on climate, we also are going to have geography playing a smaller but still important role as well. So we're going to talk about this concept of rain shadows. And these are going to be areas where warm, moist air from the ocean hits the windward side of the mountain, the area that the wind is coming in. It's going to rise, cool. Remember that cooling air condenses the water vapor and causes rain, which is going to lead to lush green vegetation because you're going to have these mountains that are kind of stopping it. Then once you have the air that has moved up, dropped all its rain, continue over that mountain, you're going to have the dry air descend down on the leeward side of the mountain, and it's going to warm as it sinks. This is going to lead to arid, dry desert conditions. Now, we here in the Western Washington live the rain shadow effect all the time. So if you just imagine that this right here is the Pacific Ocean, this right here is general Western Washington, so like Seattle, Fife, Tacoma, and then over here is going to be Eastern Washington. Rain shadow is going to explain why it rains so much here. So we are going to have the ocean, which is going to add moisture, moderate temperatures. It's going to come across, and as the wind pushes it up over, we've got the mountains here. So these would be the Cascade Mountains, Mount Rainier, etc. As the temperature tries to rise up over that, it's going to cool, which means its cooler air cannot hold water vapor. So it's going to drop it all. It's going to rain constantly. It will constantly, all the time, rain here in Fife. And then once that dry air finally makes it up over the mountain after it's risen up high, it's going to drop back down. It lost basically all of its water vapor over here on the west side. It's going to drop back down to Eastern Washington, and they're going to get dry air. which is going to lead to the desert conditions that we have on the east side and the beautiful rainy but very lush and green precipitation side that we have here on the west side. So you all should be able to grasp rain shadows because you live it every day. So that's an advantage that you have over some other people on the AP test and on understanding this concept, because this is how our local climate works because of the rain shadow, thanks to our mountains and being by the ocean. So we're going to look at another example, though, just to kind of reinforce this and get us a more global perspective. So we're going to be looking down here in South America with the Andes Mountains. So if you look here, we've got the equator, we've got our 30-degree south, we've got South America, the Andes Mountains, the arrows represent the wind. And so what's going to happen, I'm actually going to draw on this a little bit. We're going to have wind coming in from east to west, that way. And this is going to be the westward side of the Andes. They're going to receive heavy rainfall because they've got the wind coming in off of the ocean. So we're going to expect to see lots of green lush here on the windward side of the Andes. So I think I said this wrong like 10 seconds ago, but the windward side, which is the east side. Then over here, we've got the Andes Mountains, which are going to lead to dry conditions on the other side here because it hit the mountain, the water went up, it dropped all its water on the windward side, and now it's going to be the dry leeward side on the other part of the Andes. Now, another factor to take into account here is the fact that this is also about where we're having the 30-degree latitude mark, which, remember, because of Hadley cells, the air that's coming down at the 30-degree mark is going to be drier. It will have less air. So that's going to be adding even more of a contributing factor into the fact that this is just like a super dry area. We are losing the moisture from the ocean, from the wind coming this way. We are losing moisture from the air coming down from the Hadley cells. So we just have high pressure, dry area here. And if we actually go and look at satellite images, we can see this pretty apparently. So we've got here are the Andes. This is going to be on the this side of, I keep mixing up my west and east. This is going to be the east side where we have it coming in. It hits the Andes. You're going to get this really lush area. And then this is going to be your dry desert on the west side of the Andes Mountains. And if we actually zoom out, you can see this even more pronounced, this massive rain shadow coming in here. And you can basically see exactly where the Andes Mountains are right here, because you can see where we're getting lush, where we're getting desert. Now, this is going to come and bring in a lot of the concepts that we have already learned from our multiple sets of notes here. So we're going to bring it all together because AP Environmental Science is basically a lot of connections. So we're going to make some of them here. So based on what we've learned about global wind patterns from section 4.5 and solar radiation from 4.7, you can see here on this map the amount of rainfall that we are going to be getting. And you can basically tell like exactly where the Andes Mountains are just based on looking at a rainfall map. And then this also is going to connect to the fact that the Andes Mountains exist because of what we learned in 4.1 with the tectonic plate boundaries. So if you remember from 4.1, this is going to be an area where we have a oceanic crust is going to subduct under a continental crust because it's heavier. When it goes down, it's going to push up magma, which is going to lead to mountains forming, which over time gave us the Andes Mountains. So because of this connection between plate tectonics, wind patterns, and solar radiation, this is ultimately how we end up leading to these patterns that we're seeing in the rain that is occurring. So it's all connected. It's not just like one thing impacts climate or one thing impacts the characteristics that you're going to have in an area. You are going to have all of it coming together to create these climates. So now this is going to be your practice FRQ 4.8, where you're going to practice the suggested skill of explaining how environmental concepts and processes are represented visually and relate to broader environmental issues. Now this one is going to be a challenging one, so I want you to try your best for it. So I want you to look at this map here and describe the regional precipitation pattern you would expect for the portion of Mexico and Central America that's indicated on the map. So here in this red square. And I want you to justify your answer. I'm going to do something a little bit different with this FRQ. I want you to pause this video and answer this FRQ to the best of your ability. And then I'm actually going to explain the answer in a second. So right now, pause your video and answer this on your own. Okay, hopefully you pause the video because I'm gonna kind of talk you through it because this is a difficult one and I wanna make sure that you have a chance to kind of get the correct answer in a timely manner. So this is actually what we are going to see, the precipitation amounts of this area that was just highlighted in Mexico, Central America. And there's a couple different ways that you could have actually gone and explained this. Now I realize that you just saw the equator marker, but you could have kind of used some awareness of latitudes, and you might have talked about, or you could have talked about the idea of Hadley cells. So this is actually approximately, wow, sorry, that's not a very straight line. But that's approximately like our 30-degree, which if you remember, because of Hadley cells, this is going to result in a drier area because this is where we're having this air come down that doesn't have any water vapor. It's dry, it creates deserts. So that could have been one way that you could have gone with explaining what you would have predicted. You could have also talked about, if you can hear my dog in the background, I apologize. She has decided right now is the moment where she needs to destroy things. If you can't, just be aware that's what I'm hearing right now. Okay, sorry. So this is going to be where we have the winds coming in, which you could have seen on the last diagram. The winds are coming in from east to west. So you might have also been able to talk about the fact that we are going to see this rain shadow effect here on this portion of Central America because you have the wind coming in and what we just talked about with rain shadow, how it's going to dump the rain on these areas. That could have been something that you talked about with the moist air coming in from the ocean. So those are going to be a couple different factors that you could have gone through. Again, this is a pretty challenging one, so I hope that you tried your best for it, but this is going to be the full explanation for practice FRQ 4.8. Those were your notes on 4.8. So I hope you learned something.